3 ultra-faint dwarf galaxies have been discovered around a distant spiral galaxy with a mass similar to the Milky Way. The dwarf galaxies are believed to be around 12 billion years old, meaning their stars formed early in the universe's history, under 2 billion years after the Big Bang. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. At a distance of around 11.4 million years away from Earth, the ultra-faint galaxies are the first to be found orbiting a Milky Way-like galaxy outside of our galaxy's cosmic backyard, known by astronomers as its local group, which includes Andromeda and other neighboring galaxies. Despite their vast distance and origins in the early universe, the 3 ultra-faint dwarf galaxies which orbit the spiral galaxy known as NGC 253, or the Sculptor Galaxy, have characteristics that resemble ultra-faint dwarf galaxies in the local group. This means the new discovery could reveal more about ultra-faint dwarf galaxies in addition to helping unlock the secrets of the early universe and early galaxies. Our work is the necessary first step toward further understanding the faintest galaxies beyond the local group, and toward more robustly constraining the demographics of ultra-faint dwarf galaxies, lead researcher and assistant professor of physics and astronomy at Dartmouth College Mutlu Pakdal said in a statement. Opens in new tab. We still do not know whether the local group ultra-faint dwarf galaxies are typical or unusual. To answer this fundamental question, we need to discover more ultra-faint dwarf galaxies beyond our local environment and study them in detail. The 3 galaxies were first identified by the Megacam on the Magellan Clay Telescope at Las Campanas Observatory, Chile. The discovery was subsequently confirmed with the Hubble Space Telescope. Ultra-faint dwarf galaxies are considered to be the least luminous and least chemically rich galaxies astronomers know of. Low-mass satellite galaxies such as these are, however, dominated by dark matter. Dark matter is the mysterious form of matter that comprises around 85% of the mass of the universe but is all but invisible, as it does not interact with light or other forms of electromagnetic radiation. Its presence is instead theorized to exist based on observations of gravitational effects thought to be caused by this invisible matter. The fact that dark matter doesn't interact with light means that its constituent particles can't be protons or neutrons, the particles that make up the everyday matter that comprises stars, planets, and us. Thus far, the particles that make up dark matter remain mysterious. Physicists are keen to answer questions about their nature and what role they may have played in the evolution of the universe. Most galaxies are surrounded by dark matter halos that can only be inferred due to their interaction with the fundamental force of gravity, but in ultra-faint dwarf galaxies, the influence of dark matter is more significant. This means that astronomers consider ultra-faint dwarfs to be well-preserved galactic chemically pristine fossils that offer insight into the conditions in the early universe and a path towards investigating how dark matter has caused the universe to evolve. That makes these 3 distant 12-billion-year-old dwarf galaxies ideal for studying the conditions in the universe when the first galaxies began to form. Dwarf galaxies are the building blocks of larger galaxies, Mutlu Pakdal said. Ultra-faint dwarf galaxies are the best place to study galaxy formation on the smallest scales and learn how the smallest dark matter clumps get populated with stars and turn into galaxies. The team's findings were announced at the 241st meeting of the American Astronomical Society on Wednesday, January 12. Voyager 1 is the first spacecraft to travel beyond the solar system and reach interstellar space. The probe launched on September 5, 1977, about 2 weeks after its twin Voyager 2, and as of August 2022 is approximately 14.6 billion miles, 23.5 billion kilometers, away from our planet, making it Earth's farthest spacecraft. Voyager 1 is currently zipping through space at around 38,000 miles per hour, 17 kilometers per second, according to NASA Jet Propulsion Laboratory. When Voyager 1 launched a mission to explore the outer planets in our solar system, nobody knew how important the probe would still be. 45 years later, the probe has remained operational long past expectations and continues to send information about its journeys back to Earth. The spacecraft entered interstellar space in August 2012, almost 35 years after its voyage began. The discovery wasn't made official until 2013, however, when scientists had time to review the data sent back from Voyager 1. Voyager 1 was the second of the twin spacecraft to launch, but it was the first to race by Jupiter and Saturn. The images Voyager 1 sent back have been used in schoolbooks and by many media outlets for a generation. The spacecraft also carries a special record, the Golden Record, that's designed to carry voices and music from Earth out into the cosmos. According to NASA Jet Propulsion Laboratory, JPL, Voyager 1 has enough fuel to keep its instruments running until at least 2025. By then, the spacecraft will be approximately 13.8 billion miles, 22.1 billion kilometers, away from the Sun. The Voyager missions took advantage of a special alignment of the outer planets that happens just once every 176 years. This alignment allows spacecraft to gravitationally slingshot from one planet to the next, making the most efficient use of their limited fuel. NASA originally planned to send 2 spacecraft past Jupiter, Saturn and Pluto, and 2 other probes past Jupiter, Uranus and Neptune. Budgetary reasons forced the agency to scale back its plans, but NASA still got a lot out of the 2 Voyagers it launched. Voyager 2 flew past Jupiter, Saturn, Uranus and Neptune, while Voyager 1 focused on Jupiter and Saturn. Recognizing that the Voyagers would eventually fly to interstellar space, NASA authorized the production of 2 golden records to be placed on board the spacecraft. Sounds ranging from whale calls to the music of Chuck Berry were placed on board, as well as spoken greetings in 55 languages. The 12-inch wide, 30 centimeters, gold-plated copper discs also included pictorials showing how to operate them and the position of the Sun among nearby pulsars, a type of fast-spinning stellar corpse known as a neutron star, in case extraterrestrials someday stumbled onto the spacecraft and wondered where they came from. Both spacecraft are powered by 3 radioisotope thermoelectric generators, devices that convert the heat released by the radioactive decay of plutonium to electricity. Both probes were outfitted with 10 scientific instruments, including a 2-camera imaging system, multiple spectrometers, a magnetometer, and gear that detects low-energy charged particles and high-energy cosmic rays. Mission team members have also used the Voyager's communication system to help them study planets and moons, bringing the total number of scientific investigations on each craft to 11. Voyager 1 almost didn't get off the ground at its launch, as its rocket came within 3.5 seconds of running out of fuel on September 5, 1977. But the probe made it safely to space and raced past its twin after launch, getting beyond the main asteroid belt between Mars and Jupiter before Voyager 2 did. Voyager 1's first pictures of Jupiter beamed back to Earth in April 1978, when the probe was 165 million miles, 266 million kilometers, from home. To NASA's surprise, in March 1979 Voyager 1 spotted a thin ring circling the giant planet. It found 2 new moons as well, Thebe and Métis. Additionally, Voyager 1 sent back detailed pictures of Jupiter's big Galilean moons, Io, Europa, Ganymede and Callisto, as well as Amalthea. Like the Pioneer spacecraft before it, Voyager's look at Jupiter's moons revealed them to be active worlds of their own. And Voyager 1 made some intriguing discoveries about these natural satellites. For example, Io's many volcanoes and mottled yellow-brown-orange surface showed that, like planets, moons can have active interiors. Additionally, Voyager 1 sent back photos of Europa showing a relatively smooth surface broken up by lines, hinting at ice and maybe even an ocean underneath. Subsequent observations and analyses have revealed that Europa likely harbors a huge subsurface ocean of liquid water, which may even be able to support Earth-like life. Voyager 1's closest approach to Jupiter was on March 5, 1979, when it came within 174,000 miles (280,000 kilometers) of the turbulent cloud tops. Then it was time for the probe to aim for Saturn.